Right now, in a lab somewhere on Earth, a physicist is staring at an equation that shouldn't work. It describes 95% of the universe, and nobody has any idea what that 95% actually is. We've split the atom, we've mapped the human genome, we've landed machines on comets traveling faster than a rifle bullet, and yet, we don't know why you're conscious. We don't know how life began. We don't know what happens to the information that falls into a black hole. Science hasn't run out of mysteries. It's just started asking the ones it's most afraid to answer. In the 1930s, an astronomer named Fritz Zwicky noticed something impossible. Galaxies were spinning so fast they should have torn themselves apart. Something invisible was holding them together. We called it dark matter. We still can't find it. It doesn't emit light. It doesn't reflect light. It passes through solid matter like a ghost through a wall. We only know it's there because of the gravity it leaves behind. Footprints in the sand, with no one who made them. Then in 1998, it got worse. Astronomers discovered the universe isn't just expanding, it's accelerating. Something is pushing galaxies apart, faster every second. We name that dark energy. Between the two of them, dark matter and dark energy make up 95% of everything that exists. We have named the majority of the universe. We have not explained a single atom of it. 4 billion years ago, this planet was a lifeless furnace of rock, acid, and lightning. Then scientists say, somehow chemistry became biology. A handful of molecules organized themselves into something that could copy itself, protect itself, and want to keep existing. That moment is called abiogenesis, and it is arguably the single most important event in the history of the planet. We still don't know how it happened. We've built the ingredients in a lab. Amino acids form in beakers rigged to mimic early Earth. RNA fragments can self-assemble under the right conditions. But no one has ever watched non-life become life. Not once. Not in 70 years of trying. Which means the transition that created you and every living thing you've ever seen has never been witnessed by human eyes. We are living proof of an event that scientists cannot explain. The universe contains an estimated 200 billion trillion stars. Even if intelligent life is staggeringly rare, even if it only evolves once in every 10 million galaxies, the math still says the cosmos should be loud. Radio signals, probes, megastructures, something. Instead, silence. Total, unbroken, 40 billion light-year silence. This is the Fermi Paradox, named after physicist Enrico Fermi, who reportedly asked his colleagues over lunch in 1950, "Where is everybody?" The possible answers are not comforting. Maybe intelligent life is far rarer than we assume. Maybe civilizations destroy themselves before they can reach the stars. A filter every species must pass through, and most don't survive. Or maybe they're out there, watching, and have decided, for reasons we cannot fathom, to stay silent. Every year we point better telescopes at the sky. Every year the silence gets a little more precise and a little harder to explain. We can now watch your brain in real time. We can see which neurons fire when you recall your childhood home, when you feel fear, when you fall in love. We can map every single electrical signal in your skull. What we cannot explain is why any of it feels like something. There is no physical reason electrical impulses in wet tissue should produce the experience of the color red, the taste of coffee, the ache of nostalgia. Philosopher David Chalmers called this the hard problem of consciousness, and 40 years later, it's still unsolved. Some scientists think consciousness emerges from complexity itself. Others think it might be a fundamental property of the universe, like mass or charge, present in some form even in particles. A few, only half joking, suggest we may never solve it, because you can't fully study the thing doing the studying. You are, at this exact moment, having a private, unexplainable experience that all of modern science cannot account for. Black holes shouldn't be controversial. We've photographed one. We've detected the gravitational ripples from two of them colliding, 100 million light-years away. But at the center of every black hole sits something physics refuses to describe. A singularity, a point where density becomes infinite and our equations simply stop working. Not give strange answers. Stop. Break down entirely. Worse, black holes create something called the information paradox. Physics has a sacred rule. Information can never truly be destroyed. But when something falls into a black hole, and the black hole eventually evaporates, as Stephen Hawking proposed it must, where does that information go? Nobody agrees. Some physicists think it leaks out, encoded in the radiation. Others think it's smeared across the event horizon like a hologram. Hawking himself changed his answer more than once before he died. We built a device to photograph the edge of a black hole before we figured out what happens at its center. Somewhere in your cells right now, tiny caps on your DNA called telomeres are shortening, one division at a time. This is one theory for why you age. It is not the full answer. Because here's the strange part. Aging isn't universal. Certain jellyfish can revert to an earlier stage of life and effectively restart their biological clock. Some clams have lived for over 500 years. Naked mole rats barely age at all and rarely get cancer. Biologically speaking, death by old age is not a law of nature. It's a setting, and in a handful of species, that setting appears to be off. So why is it on for us? Some researchers argue aging is programmed, an evolutionary trade-off for early reproduction. Others argue it's simply accumulated damage with no off switch we've found yet. Billions of dollars are now being spent trying to answer this single question. Because if aging is a setting rather than a law, that means, in principle, it might be adjustable. We don't know yet. But for the first time in human history, we're not sure the answer is no. Every era in history believed it had mostly figured things out, right up until it didn't. The physicists of 1899 thought physics was basically complete. Then came relativity, quantum mechanics, and the atomic age, all within 30 years. We like to think we live in an age of answers. The truth is, we live in an age of extraordinary questions, bigger and stranger than anything our ancestors could have imagined. If this kind of deep dive is your thing, subscribe, because this channel exists to chase exactly these kinds of questions.